Hello, mic test. Okay, hello to Jessica. Or should I say Jazel? Uh, 悠悠自在 Aaron, 安伟仪 Gilbert, Janavi, Lin Mam, Jais Rose, Mani. Okay. Alright, looks like everything is good. Okay, can change back to this mode first. Okay, hello everyone. It's good to be back on Wednesday. As you all know, last week we had to push back the Facebook Live to Friday because of the PSLE oral exams. So hopefully none of you got affected and that you were able to concentrate on your exams. Okay, I know that we don't do oral exams, neither do we do English or Chinese, but it's not really about, how to say, it's not just about maths, you see. I hope that you all will be able to perform well in every subject that you focus on. Okay, so it's good to be back on Wednesday. Okay, so anyway, hello to Polly, Pina, Felicia, Delvin, Edison, Rekha, FTB, Eunice. Okay, so anyway, a bit about myself. My name is Kevin Huang. I'm the curriculum specialist here at Maths Heuristics. So I've been teaching here for 8 years already. So hopefully there'll be more things for me to do at Maths Heuristics because I really like where the company is going. I like its direction. And I also definitely like teaching the kids. The admin stuff is a bit dry at times, but teaching is what I really enjoy doing. Okay, so a bit about all these things. We have produced the Mastering Heuristics series. It's a title of 5 books written by my boss and my mentor, Mr. Sani Tan. So he has been coaching me in how to teach students since day one. And right now I'm sharing the fruits of his labor with everyone. Okay, so all these books comes along together with web videos, mobile apps access, and of course they'll be sent to you via SingPost registered mail. Okay, if you want to purchase it later, I'll give you a link for that. But anyway, let's talk about today's topic on angles. So as you know, some of these angles problems can be quite challenging. Okay, you will probably realize that forced drilling does not work at all for this topic because it specifically tests your child's ability to manipulate and the given sizes and relative positions of the figure to try to fit into certain definitions. So in case you're wondering how important this topic is, it can constitute up to 6 marks and often appear in the section C of the exam, or rather paper 2. Okay, so today I'll break down a few things for everyone. Okay, hello to Audric and Brian. Okay, so let's get started. Before I go into the lesson proper, let me just recap with everyone on the properties of angles. For those of you who have not used angles for a very long time, here's the properties. Okay, so for angles on a straight line, all angles on a straight line adds up to 180 degrees. Okay, then for vertically opposite angles, you will see that if you have 2 straight lines over here, angle A is going to be the same as angle B. And angle C is going to be the same as angle D. Yeah. Okay. The next up, angles at a point. You can think of an angle at a point by drawing a straight line through and considering both the degrees, both sides. Both of these is going to add up to 180 degrees times 2, which will simply give you 360 degrees. Hello to Ken. Okay, so next up, on alternate angles. When these alternate angles and corresponding angles occur when you have parallel lines. So parallel lines, just so that everyone is clear, parallel lines are lines that are drawn at the same angle in space. So when you draw these two lines are very sad because they will never meet each other in their life. Okay? If you draw it and extend it to infinity, they are never going to meet each other. Okay, so they are drawn at the same angle. So when you cut a straight line across this, the alternate angle over here is that this will be angle A as well. Okay. Then the next one is on corresponding angles. Corresponding angles is very similar. However, now if you draw this straight line through the parallel lines, this will also be your angle A. So you can also say that from this alternate angle property, because it's vertically opposite, it will also be a corresponding angle, and vice versa. Okay, hang on, let me turn off my tablet sound. Okay, so parallel lines are important. Later on I'll explain why in a while. Okay, because with parallel lines they come with several properties that you can use. So that's for corresponding angles. Now let's look at a rhombus and a parallelogram. Okay, I took away the rectangle and square. Okay, but anyway, okay, for this rhombus, you will see that the opposite sides are equal to one another. Wait, no, sorry. The opposite sides are parallel to one another. Okay. So all the lengths are the same. And angle A over here is the same as angle C, because if you are to extend out all these parallel lines, okay, you will see that this is in fact angle A, because they are the same lines that are drawn in space. I mean, they are lines that are drawn at the same angle in space. So this is in effect angle A. So for angle B will be the same as angle D. So that's one way you can use to try to understand these quadrilaterals better. So angle A plus angle D, you can also extend this out. You will see that angle A falls over here. Angle A plus angle D would add up to 180 degrees. Angle B and angle C also adds up to 180 degrees. So there are of course two more combinations, angle A and angle B will add up to 180 degrees. Okay, because if you extend this down, angle A will be here, and it's a straight line. Angle C and angle D is also going to add up to 180 degrees. Okay, then the beautiful part about a rhombus is that if you cut this across by this diagonal or by the other diagonal, you are going to obtain isosceles triangles. Okay? Then next up, for parallelogram, think of a parallelogram as a tilted rectangle, where they have, okay, the only difference here is that the lengths are going to be different. Opposite sides are parallel still. The length of AB is going to be the same as the length of DC, and the length of AD is going to be the same as the length of BC. Okay. So angle A again is going to be the same as angle C, angle B is going to be the same as angle D. All these are going to add up to 180 degrees, and of course there are two more combinations, A and D, B and C. They will add up to 180 degrees. Okay, so then the next part here is that, okay, for a square, the issue about a square is that you have to be careful is that all four sides are equal, all corners are 90 degrees. And for a rectangle, this side is equal to this side is equal to this side. All angles meet each other at 90 degrees. Okay, so when they say that a shape is a rectangle, they usually don't tell you that for fun. They tell you that because there are certain properties that you have to use. Okay, and this line is parallel to this line parallel to this line. Okay, then finally for a trapezium, yeah, please stop yeeting here. So for a trapezium, there is one thing you have to be very careful of. The sides that will add up to 180 degrees are these sides over here. Okay, you can check, you can try to extend out this line over here, and you see which angle is going to fit into that straight line. This will be for angle B, this will be for angle C, this will be for angle D. So try not to memorize all these properties. Try to understand them from some basic properties, such as angle on a straight line, vertically opposite angle, and all these alternate and corresponding angles. Okay? So anyway, these would add up to 180 degrees because they lie on a straight line. Okay? The misconception that I see quite a few students do is that they think that A and D adds up to 180 degrees. No, it doesn't, because you can see that visually both of them are already obtuse. There is no way that these two can add up to exactly 180 degrees. It's going to be more than that. And similarly, both of these angles are acute. When you add two acute angles together, you are going to end up with something that's less than 180 degrees. So that cannot be the case. Okay, so when in doubt, try to derive the properties on your own to have a greater understanding. Okay, so these are the basic properties. So let's go on to the lesson proper. Okay, so before I start, here are a few things that I'd like you to take note of. Okay, let me retrieve my notes first. Okay, for geometry, there are a few things that you need to take note of. And these are the things that I would recommend. Yeah, I'm just going to use pink because I can. So the first thing that you need to do is use pencils for markings. Okay, the reason is that it's easier to erase. If you make a mistake and you try to use the Blanco over it, from what I understand, it's highly recommended that you don't use correction fluid or correction tape in PSLE. So you better use a pencil in case you make a mistake. Okay, second one is to mark out all equal lengths and angles. Because when you know which ones are the same, which lengths are the same, you can either figure out that this is an equilateral triangle, this is an isosceles triangle, or it can lead you to some other property. The third one is to mark out or take note of parallel lines. Because with parallel lines, it unlocks two main properties. The first one is the alternate angle. Second one is corresponding angle. Okay. Oh, and shapes as well. Because for shapes, when they tell you that it's a parallelogram, you are expected to know that the two opposite angles are the same. Opposite sides are parallel. What else? And if it's a rhombus, all sides are equal. Okay? Okay, the fourth one is to allocate units whenever possible. Okay? How come you all got so many smiley on? If you are as enthusiastic as showing off your smiley as much as you are in showing off your skills for maths, I think you all would do very well in it. Okay? Take this form of intelligence and apply it in your studies. Believe me, this is what works well. This is the thing that will pay off. Take this form of intelligence and put it to your studies. Okay? Why you rub hand? Okay. So anyway, let's go on to the main thing. Now let's talk about a few common techniques. In the figure below, not drawn to scale, a piece of paper that is of the parallelogram shape is folded at corners A, B, and along the line CD as shown. Find the angle X. So this is a parallelogram piece of paper. Like, who would cut it in the parallelogram piece of paper? Okay, so I've prepared a little parallelogram for you, just to show you how it's like. Okay? Hang on, yeah, let me set to the big video first. Okay. So you all see this piece of paper? It resembles the one in the question. It's just that right now I have a physical one. By the way, one of the more practical ways you can learn about geometry and net shapes is to really physically take the paper and cut out the shape and fold it and try to manipulate it. Okay, that way it will allow you to understand the whole situation better. So, okay, see when you unfold this angle was marked as your 65 degrees. If you unfold it, this 65 degrees is still going to remain as it is. And if you unfold these two things out, if this guy here, hang on, okay, if this guy here is 65 degrees, this angle here has to be 65 degrees as well, by properties of a parallelogram. Okay, let me see if the camera angle is correct. Yeah, it's correct. So you can't really unfold the piece of paper on the exam, but you can do a rough sketch of it. Okay, if you're bad at drawing, don't worry. As long as you can draw a stickman, you can definitely sketch this out. If you can draw a stickman, you should be able to sketch it out. So originally, it should have looked somewhat like this. Correct? And this is 65 degrees. This was also 65 degrees. And this angle came from where? This angle came from here. this guy here. Okay, then the next one is, by properties of a parallelogram, if this is 65 degrees, this has to be 180 degrees minus 65 degrees to give you 115 degrees. So this must also be 115 degrees. Okay. Oh, I forgot to change back. It's the first time I used that mode for quite a while. Okay. NG. Let me do that again. Okay, so here let's discuss this again. So you can sketch out the parallelogram first. Okay, you can see that if this is the parallelogram, this is 65 degrees, this should be your 65 degrees, which means that this has to be 65 degrees. And once you unfold it out, it becomes a lot clearer to see that this angle has to be 180 degrees minus 65 degrees to give you 115 degrees. Correct? So after that, when you unfold this portion, okay, please take note here, this is going to be 30 degrees. Okay? This is going to be 30 degrees and it's going to lie on a straight line. So the next part is, if this is 115 degrees, this has to be 115 degrees as well, because this will be your 115 degrees that you folded up over here. And within this portion is a triangle. So this last angle here has to be 10 degrees, because all the interior angles add up to, of a triangle, add up to 180 degrees. So if this is 10 degrees, this here must also be 10 degrees. And the thing here is that they all lie on a straight line. They're not thick enough. Okay, they are all supposed to lie on a straight line. This one is too thick. So angle X can be simply said to be 180 degrees minus 180 degrees minus of the 30 degrees minus 30 degrees minus 10 degrees minus 10 degrees. So that will give you 100 degrees. Okay, this will be your answer. Okay, please take note that there are two 10 degrees. One is here, and the other one is when you unfold it. There will be another 110, another 10 degrees being produced over here. Okay. Yep, so the whole idea about unfolding is you want to sketch it out first when in doubt, and understand that when you fold something, it's going to produce a line of symmetry. So when you unfold it, it will produce the same exact angle over here. Okay? Alright, if you got it, please spam the like button. Okay, got it. Okay, very good. Let's move on to number 2. Okay, in the yeah, Jaslyn, when you fold back the paper, it will produce the same angle over there. Okay, second question. In the figure below, not drawn to scale, you want to find the sum of all these angles. Okay? So you will notice that by now, you will notice that my presentation slides and your paper printout is quite different because I need the space to write. Okay, that's why my picture is a bit smaller. Okay. Sorry, please add in one more line over here. All lines are straight lines. Okay. How do I move this? All lines are straight lines. You want to find the sum of all these angles. So, in order to do this, you can see that there is not enough information for you to find the individual angle. Like for example, if I want you to single out and find the value of angle A. That is impossible because there is not enough information. So what can be done instead? Now over here we can say that if all your lines are straight lines, then if this is 25 degrees and this is 38 degrees, this angle here has to be 180 degrees. Minus 25 minus 38 degrees to give you 117 degrees. Okay, I know of a shortcut, but I'm not going to go into that because that is more of a secondary school kind of theorem. So if this is 117 degrees and this is a straight line, then this angle here has to be 180 degrees minus 117 degrees to give you 63 degrees. Yeah, the lines will meet. Not necessarily. No, this is not a square to begin with. Okay, so once you got it already, you will see that by vertically opposite angles, this guy here is also going to be 63 degrees. Okay, and because all of them are straight lines, we can observe that we can form several triangles like these. Okay. So once we've got that, we can conclude something. We do not need to find its individual area, individual angle, because we are required to find the sum of all these angles. So let's just ignore the individual value part, and let's just say that we can observe now that A and B has to add up to 180 degrees minus 63 degrees to give you 117 degrees. So this is for A and B. C and D is also 117 degrees. And by the same reasoning, your G and H is also 117 degrees. E and F is also going to add up to 117 degrees. So you will see that by grouping them up, you can get rid of that uncertainty. See, so the idea here is on grouping. 4 times 117 degrees will give you 468 degrees. Half times base times height. Yeah, okay, SG, you got it. 悠悠自在Sandia, you got it. The method is on grouping, Elaine. Ang Wei, you got it. Okay, so by grouping them up, you can say for sure that both of these will add up to 117 degrees. But you cannot find out G, you cannot find out H alone. You cannot find out G alone, you cannot find out H alone. Okay? Yeah, this is for primary 5 and primary 6. Okay, so let's go on to the next one. Okay, please spam the like button if you got it. I also want to log in and spam, but I can't really do it. Don't know why. Ah, okay, I think I got it. Okay, good. Then let's carry on. Now, number 3. Okay, let's take this a bit further. The idea of grouping. Don't worry, Delvin, you can handle it. You just need to know that the interior angles of a triangle always adds up to 180 degrees. Okay, don't worry, Delvin, you can handle it. You can handle my P5 UTM, you can handle this. Okay? Put yeet if you got it right. Okay, now, okay, in figure 3, no, in question 3, in the figure, JK, LM, WX, and YZ are all straight lines. You want to find the sum of all these angles. So again, by now you would know that you do not necessarily have to find the individual value. So we can group them up together. But now this time around it's a bit tricky. Okay, so let's look carefully at this diagram first. We see that this is an equilateral triangle. So let's say that this is 60 degrees first. Okay, all these are 60 degrees. Then, if this is 35 degrees and all these are straight lines will trigger the vertically opposite angle property. If this is 35 degrees, this must also be 35 degrees. And 60 degrees is here, this also has to be 60 degrees. Correct? Okay, Fiona, you got it? No, it's not 720. But some of you got it already. Okay, so now you see what we can do next is to try to list out everything first. You see that your angle A plus B plus P. Well, why is it lagging? This will add up to 180 degrees. Okay, your angle C, D, and Q going to add up to 180 degrees. Your angle EF and R adds up to 180 degrees, and G, H, and S is also going to add up to 180 degrees. Correct? Because they are all triangles. So now you've just focused on what is required. Okay, they won't set something that is impossible for you to find. You want to find this sum. And you will notice that you want to get rid of P, Q, R, and S. What else can we use over here? We can see that all these angles about a point are going to add up to 360 degrees. So in order to deal with this, we want to know what is P, Q, R, and S. We have to isolate them out. We have to get rid of this 60 this 60, this 35, and this 35. So P, Q, R, and S is going to add up to 360 degrees minus 35 degrees minus 35 degrees minus 60 degrees minus 60 degrees. Okay, this will give you 170 degrees. So if this whole thing is 170 degrees and I want to get rid of them from all these four triangles, the answer would simply be 4 times 180 degrees minus 170 degrees. This will give you 550 degrees, which is your answer. Okay? Yeah, see, I told you, Delvin, you can do it one. Jazel also, you know what's going on. Definitely you know what's going on. You're one. You've been following me in the 10OP for quite a while. And I would say since the beginning of this year. Okay? My big head is not blocking, right? Okay, yeah. My big head is not blocking. Okay, you got it. Please spam the like button. If you didn't, don't worry. So this one I think will end a bit later because I still got 2 more questions. Okay. Alright. Okay, let's go on to number 4. Hey, please do not spam. Please do not spam the chat. Okay, so let's talk about 2 more things over here. This is quite a popular problem that I've seen posted in a few forums from time to time. Okay, so let's look at it this way. The figure below is a star shape that has been formed by many straight lines. You want to find the sum of these 3 angles again. So you see when you want to find the sum of angles, usually it means that you do not need to care about the individual value. Okay, usually that's what it means. So the shortcut here is that all these 5 angles is going to add up to 180 degrees. Okay, then if you give another student this type of question and you tweak it a bit, that student is just going to try to memorize that theory and put it in. I can guarantee you this. If you try to just let them memorize the theory without letting them understand how it comes about, they are going to get it wrong. Okay, they need to know exactly how it's derived and understand the ideas behind it to solve unfamiliar problems. Okay, this whole Facebook live session is not about solving a few particular problems. It has always been about sharing the thought processes on solving unfamiliar problems. Okay, my friend just got a world record yesterday night. I'm pretty happy for him. But anyway, let's talk about this. Okay, so to solve a problem like this, all these are straight lines. Okay, now let's look at what we can do. For this problem, it doesn't really matter which angle or which triangle you look at, but try to isolate 2 triangles first. So this red triangle over here, all its angles are going to add up to 180 degrees. Okay, 180 degrees, and you have a B and a C, and of course you have this little unknown angle here. This little unknown angle here will be this fella over here. Okay, so based on this part-hole model, you can see that this has to be 180 degrees minus B minus C. Agree? It's going to be the straight line 180 degrees minus B minus C. So if this lies on a straight line, this angle here would have to be B and C. Okay, a lot of you got the answer already. So please listen to the explanation. Okay? Then I can drag out another triangle and look at it. I can drag this triangle out. And by that same reasoning, if this angle here is A, this angle here is 40. This last angle has to be of a value that when you add together with A and 40 degrees, it gives you 180 degrees exactly. So 40, okay, wait. Okay, there's an angle A here, there's a 40 degrees here, so there will be this left over here. Now this angle will be 180 degrees minus A minus 40 degrees. So basically it's going to become 140 degrees minus A. Okay? Now Delvin, you don't know this one is okay, because this one a lot of P5 and P6 also don't know one. So here I'm to explain it to them. So this angle here would have to be 1. Because this lies on a straight line, this angle is over here. So this would have to be your blue angle. This would have to be A plus 40 degrees. Okay, don't worry, Elaine, later you watch the replay when it's up. The main ideas involved here is that you have to look at the interior angles of a triangle. And when you extend it out, this straight line here, you will get this angle and this angle. If you're P4 and you don't understand this one is quite normal. Okay? Try not to let it eat into you. So when we look at this green triangle, we can see that A, B, C, 40 degrees and 25 degrees is all going to add up to this 180 degrees here. Which means to say that your A plus B, okay, think of it this way, let's just draw out the part-hole model. A, B and C, 40 degrees and 25 degrees. The whole thing adds up to 180 degrees. So your A plus B plus C would have to simply be 180 degrees minus 40 degrees minus 25 degrees. Okay, this would be your answer. Okay. Yeah, you all got it. Pretty good. So try to isolate the shapes first whenever you can. Yeah, 115. Okay, so I need to speed things up a bit. So let's go on to number 5. Okay. Now let's talk about this question. The figure below is not drawn to scale. ABCD, this one, this figure is a rectangle, and this P, Q, R, and C are similar rectangles which overlap to form angle Y. So E, F, C, H is a square. So when they tell you, like what I said at the start of the lesson, when they tell you that a shape is a rectangle and a shape is a square, usually there is a reason behind it, especially for problems involving angle. Okay, Delbert, the green one was interior angles all add up to 180 degrees. So given that your FCR, this angle here, is 35 degrees, HCD is equal to BCH. Find angle Y. Okay, so this angle HCD is the same as BCH. Correct? So what else can we say here? We can say that because all these are rectangles and squares, this angle is going to be 90 degrees. Correct? Okay, this is going to be 90, without messing up the diagram too much, this is going to add up to 90 degrees, and it is evenly distributed between two units here. Okay, this is what I mean by allocating your units. My God, this one is difficult to write. So if 2 units is 90, 1 unit would have to represent 45 degrees. So let's just change it and simplify it out. This one will be 45 degrees, 45 degrees. Okay. Now this guy here is 35 degrees. So what else can we look at? Okay, Felicia, I think I know what you are trying to say. So let's look at this carefully, because this is a square, correct? And this HCB is 45 degrees. This angle here is also going to have to be 45 degrees. It's going to have to be 90 degrees minus 45 degrees to give you this 45 degrees here. Okay, I think most of you got it already. So once we know this angle and we know this angle, we can now look at this rectangle over here, because this is going to have a right angle, and angle Y is just going to be 90 degrees minus 45 degrees minus 35 degrees. Then this will give you 10 degrees, which most of you got. Pretty good. Okay? Yeah, your son is okay, Jennifer. Shelvin is alright. Okay, yeah, so let me just summarize everything. Can I copy and paste? Okay, so the summary part, as you've seen, first you want to use pencils for marking out all your lengths. Then next up, you want, never mind. Okay, I'll just come back to this page. Things to take note for angles. Use pencils for all your markings, because your correction tape, correction fluid, all that is not recommended for you to use in PSLE. You want to use a pencil just in case you mess up, you can at least still erase it. Okay, then you can go back to the original drawing and try to work your way out again. Second, mark out all equal lengths and angles first. This will give you a clue of what to do next. Usually it unlocks certain properties. Third, take note of parallel lines and what the shapes are, because all these things, parallel lines will unlock certain properties. When they tell you that a shape is a rectangle, it's going to have right angles, it's going to have parallel lines. When it's a rhombus, it's going to have all sides equal, so you can cut the diagonal across to give you isosceles triangles, that kind of thing. Okay, it's going to unlock several properties. Then number 4, allocate units whenever possible, like what I did for the last question. Okay, so this is the main summary. They did not say, okay, to clarify on the correction tape thing, they did not explicitly say don't use. They say strongly not recommended. You go and interpret how you want to interpret it is going to be up to you. Okay? Yeah, welcome, Yip. Okay, so anyway, that's the end of today's presentation. Okay, so for this September holiday, we'll be holding several holiday programs at Maths Heuristics. This will be held at Gold Hill Center because right now we are collaborating with Good School Learning. So there's a few more other branches. I have to specify that these holiday workshops are going to be held at our Gold Hill Center office. Okay? It will not be held at Kovan or Tampines, it will be held at Gold Hill. So you can refer to this link over here. Let me try to type it out. Okay, you're welcome, May. No, in PSLE itself, right, I do not recommend you to use correction fluid and correction tape because the authorities have already specified not recommended. Okay, wait, let me type this out real quick. mathsheuristics.com/schedule. Can I log in? Oh, what's wrong with this? Oh, no wonder it's lagging. Okay, wait. Okay, you all got that? Yeah, okay. I think I don't really have a choice. I have to keep this up and running. Okay, you're welcome, everyone. What world record did your friend win? House of the Dead Scarlet Dawn. Master mode. No, okay, about the world record thing, this is what my friend did. Because both of us are very, very dedicated to gaming. So the whole idea here is I have 4. He has got 1 world record now. The thing here is you realize that I focus a lot on thought process. Okay, you realize one thing, I focus a lot on thought process. Because I do not just want to solve a particular problem and that's the end of the story. I want to know that thought process so that in future, whatever problem comes, I can solve it using that same thinking process. And this is very important in today's economy because in 10 years' time, the world that you know today is going to be very different because of all the AI things coming up, all the new technology coming out. Change is going to happen at a very rapid pace. So you are going to need to focus a lot on your thought process to deal with all the unfamiliar problems, not just in maths, okay, but a lot more in life. Okay, you're welcome, everyone. If you observe one thing about me, from day one, I already talk about thought process. And that is the reason. Okay, if you want to, okay, then the next thing you realize, if you observe what I've been saying, right, is that one thing I believe, all kids are intelligent in their own ways. Okay, but a lot of us are, okay, I'm also guilty of this. Let me be very frank with you. A lot of us, when we are younger and we don't know much things about the world, we tend to just go with what we like to do. Okay? So I spent a lot of time on gaming last time. Like, whatever you all are gaming now, to be honest, I don't think you game as much as me last time. But then I would say that you can take this form of intelligence. Okay, if you all bother to go and research on your Fortnite, on your Minecraft, on whatever, Grutopia I think is dead. But I think Minecraft is researching now. Okay, if you bother to research all these things, if you take that attitude, you take that work ethic and apply it in your studies, I'm sure you'll go very far. Okay, you can prove me correct on this. Okay? So I guess that's all I have to say. Okay, you all have any questions? Take your intelligence and apply it into academics. Which is not a bad thing, because to be honest with you, Minecraft is a game that I personally don't see any end to it. I don't play it either. But maybe you enjoy it for some reason. Maybe it's fun to build all those things. Personally, I never played it. My son don't make note for schoolwork, but he made notes for Minecraft. You take the note-taking skill from Minecraft and apply it to your studies, right? You confirm will be very, very powerful one. Yeah, but technically, I think it's on the meta. You can say that. Fortnite is already dying. Apex, I heard, also is dying. Correct? But Minecraft is like researching. Personally, I never really like Fortnite. I find it too kiddish. In our time, we used to play Counter-Strike. Link for this, okay, the link for this you can go to, okay, for Lynette, okay, Lynette, the thing here is, you can come to this part, mathsheuristics.com/blog, okay. This is the part to download the notes. Okay, so anyway, I think let's end the session now. Okay, this is Kevin from Maths Heuristics signing off. See you all soon. Good night, everyone. Thanks for tuning in.